So we're talking about set theory, and since all of we kind of already did sets before, let's see if everybody could remember or try to recall what you remember about set theory or sets, right? So so you guys tell me what you guys remember about set theory. It could be anything at all. It could be anything at all. But what do you remember about set theory or sets? What are some of the things?
Types of sets.
Types of sets. Okay, what are there types of sets? I don't have time to deal with you guys right now. I need to start my class.
I remember elements within the set, like to make up.
So I think it was Scotia says types. You saying elements. Okay, that's cool. That is a word. Or anything else? Anybody remember? Anything at all? What do you remember from sets? Well, yeah. I guess those are operations really. So you have union. You have intersect. Or what else? Anything else?
It includes like real numbers.
Right. So we could put things. I mean, it include. Is it only like real numbers and that kind of stuff? I mean, is it only that? So do you need numbers to create a set? So what is a set then? Oh, that's very good. Thank you very much. So a set, and the definition here, and I like it, is a group of things that is according to Scotia. So is it a group of any things like say I have a phone here, I have a book, I have a pen, I have a mouse. Is that a set? Could it be anything? So anything is a set? Right, no, so it is a group of things that have something in common. And this is a super important topic, not only in maths, but in life itself. In life itself is a group of things that have something in common. Yeah? So for example, could you give me an example of a set? What's a group of things that have something in common? Alright, yeah, so you have the days of the week. Example, the days of the week. Yeah, they all have something in common. So I could say, let's call it set A. Oh no, let's call it this one. Let's call this one set U. And set U, and a way to look at how I'm doing it, I'm gonna put curly brackets, and I'm gonna put the set of days of the week. Close bracket. Right? So I gave the set a name, and in this case is U, and I open curly brackets, and these curly brackets literally mean the set of. So U is the set of days of the week. So everybody understand how to write a set? Right? Pretty simple, right? Simple, easy stuff, right? Any other examples of sets? Types of cars, right? So U could be types of cars, the set of types of cars, right? So you see how I wrote it out like this, right? But then I could also, let's go back to days of the week. I could also write it like this, where I have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and on Sunday, and then that's it. That is all, right? So you see, I could write it in two ways. I could either write it as an English statement, or I could write out all of the elements in the set. So in this way, I wrote it out as an English statement, or I could write out all of the elements. What are all of the types of cars? You have Honda, you have Hyundai, or whatever, the knockoff of Honda. What else you have? BMW, right? And dot, dot, dot. Now you notice what's the difference here. You notice that in this one, I have all of the elements. So I just write all of the elements and I close the set. But in this one here, I don't have all of the elements because you can't possibly list, well you could, but it might probably be hundreds of different types of cars, or maybe even thousands of different types of cars. So you're definitely not going to be able to list out all of the elements. So you could just put dot, dot, dot to show that there are more elements in the set. So at the end of the day, when you write English statements, this is called the set builder form. And when you write out all of the elements in a list, this is called your roster form. So this here is the set builder form. This is where you just write it as an English statement. And this here is your roster form. Nice. Now you know sets is something that is get quite a bit tricky, right? Now let me talk about this days of the week thing, right? Or let's talk about days of the week, right? So days of the week, so U is equal to the set of days of the week. Right? You notice I keep using U, right? U also means universal set. The universal set is the biggest set that you are thinking about. The biggest possible set, and it is usually drawn in your Venn diagram as a rectangle, right? And we'll talk about what a Venn diagram is very soon, right? But then now I have other sets. So I can have the set T, which are days that begin with T, right? I could have S, the days that contain the letter S, right? Right. So, what else? Yes, right? So let me ask you something, right? What form is this that I write this in? Thank you very much. Now I want you guys to tell me what are the elements. So we'll list the roster form for me. So what's the roster form for you? What is that going to be? No, for you.
Monday to Sunday. So Monday, Tuesday.
Wednesday, Thursday, Friday, Saturday, and Sunday. Nice. What about T? Tuesday, and Thursday. What about S? Saturday. Not days that begin with S, you know, days that contain a S.
Tuesday, Wednesday, Thursday,
Saturday, Sunday, and Tuesday, right? So it's just Monday and Friday don't have S's, right? So look at these guys now, right? You can see that I have different sets. The universal set contains all of the elements, right? Is it cool to say that T, the set T, is inside the universal set? Would you say that? Would you say that the set S is inside the universal set?
Yeah.
Yes. Would you say that the set S is inside the set T? No. Would you say that the set T is inside the set S? Yes. Yeah. So the set T is actually inside of the set S. So the thing is, right, that we could represent this information, right, so I could actually draw something called a Venn diagram to represent this, all of this information, right? So the Venn diagram now, remember, U is the biggest set that we're dealing with. That set have all of our elements in it. Right? You see, look the message in there. Gosh, all of this is be real hell to edit out of the video. I don't have time for you. That is not them. That's somebody else. Right. So U is the set of days of the week, and this have everything in it. Right? So at the end of the day, if you notice, I have all you're telling me that the entire of set T is inside a S. That's what they're saying, right?
Yeah.
Right. Are there any elements in set U that are not in T or S?
Friday.
Friday alone?
Monday.
Right. So Monday and Friday, them not in T, them not in S. So I gotta write them first. Monday and Friday. They're in the universal set, but they're not in T and they're not in S, right? So now I am going to write S. S being what? Saturday, Sunday, Wednesday, Tuesday, Thursday. Right? So we see here that we have the set S, and we also see here that Tuesday and Thursday gives me the set T. And you could see that the entire of the set T is inside of the set S. Makes sense to you all, right? Yeah? So at the end of the day now, and this is just a reminder, right? What we could start to say here is, okay, well, we could start to see that S is a subset, is a proper subset of U, sorry. So everybody agree with that? Yes. S is a proper subset of U, and we'll talk about this proper subset thing just now, right? T is also a subset, a proper subset of S. Would you all agree with that? And we could also say that T is a subset, a proper subset of U as well. Would you all agree with that? Right. So this is just a little revision of sets. Right? We could see here that we have something called an intersection. So let me ask you something. Does T intersect S? Let me see if you all remember this stuff. When they have stuff in common. So T don't have nothing in common with S? Yeah, well no, they do have stuff in common. So yes, there is definitely an intersection. So yes, T does intersect S. So once they have something in common, T intersects S. So the intersection T intersects S is the set that will have Tuesday in it and Thursday in it, right? Is that cool?
Yeah.
We could also see that the set T intersect S is equal to the set T. Make sense? They're the same thing, right? Right. What about union? What if I said T union S? And that is not how it is right, union. You don't write it like a U, it's a horseshoe, so you just go up like that. Union S. What is T union S?
That would be Saturday, Sunday, Tuesday.
Right. So what you're trying to tell me is everything in T as well as everything in S, eh?
Yes.
So it have what? Tuesday. It have Wednesday, it have Thursday, no Friday, it have Saturday, and it have Sunday. Eh? So this is T union S. Everybody cool with that?
Yes.
Right. And then we have complement. So let me ask you a question now. What is T union S? Complement. What does that mean? Right. So a complement means everything outside or everything other than. Right. So T union S. I don't want anything from that. I want everything outside of T union S. So what is that going to be now? Very good. So this here was our little revision here, just to jar your memory on what sets is all about. You can see that sets are a very easy topic. But at the same time, them questions can hit you hard. This sets here, mathematical set theory, is actually one of the basis for logical thinking. When a person could think logically is because they could separate things into categories or sets. Yeah? So sets is one of those basic skills that you need for critical and logical thinking. What is a set? The definition? Well, simply put, it's a collection. First we specify common property among things. A common property among things. We'll define this word later. And then we gather all of the things that have this common property. So for example here, you see the items you wear. This is a set. The items you wear. And these are the elements of the set. So you can see that items you wear, what do they have in common? They have in common that you wear them, right? So we can see here that we have the curly brackets, the set of and then the roster form where we listed out all of the elements in the set. And I'm sure you could come up with at least 100. So this is what is known as a set, right? So a set basically is just a group of things that all have something in common, and you could write that as the definition. A group of things that all have something in common, right? Another example are the types of fingers, right? So the set includes these four types of fingers: index, middle, ring, and pinky. Yeah. So you see that you have 4 different types of fingers. Is anything missing from this set?
Thumb.
Right. But no, the thumb is not missing, because did you know that your thumb is not a finger?
What is it?
It's a thumb. It's an opposable thumb, right? But your thumb is not a finger because it opposes the fingers, right? So it is not. So when you say that you have 10 fingers, you lie. You actually have 8 fingers and 2 thumbs. You understand? So yeah, I bet you all didn't know that, right? I'm sure you all would. I should say you knew that, right?
I think you had mentioned it when we was in class physically before.
Yes.
But I don't know why I'm feeling shocked about it all.
Yeah, it's something people tend to forget. You only have 4 fingers and a thumb, right? Now, in terms of set notation, and you can see here, there's fairly simple way that we could write set notation, right? In this case here, this is the roster form. So when we have the curly brackets and writing out the elements of the set, right? That is what we call the roster form of the set. So just make a note of that. So the roster form is when we have all of the elements of the set. The curly brackets, literally, you could read it as the set of. You can see here that each element is also called a member, so they mean the same thing. And the 3 dots here means that the set goes on forever, or is an infinite set. Now I actually do agree with this. The 3 dots don't necessarily have to mean that it's infinite, right? The 3 dots could just mean that, hey, I'm not going to write out all of the elements. There are more elements in the set, right? So over here, the 3 dots means to continue on, and I agree with that more. Yeah. So this notation for the previous examples, so you see here that they wrote it here. So before they wrote it in set builder form, right? Types of fingers, that is the set builder form, and items you wear, that is the set builder form. And over here, the items you wear and the types of fingers, these are your roster forms, right? Everybody okay so far? No questions? Everybody cool, right?
Yeah.
Alright, cool. Yes, I know it's a boring class today. I know that, right? But it's important to remember all of these things, because these are the things that mess us up when the exam, happens, right? So you can see here the difference between an infinite set and a finite set. An infinite set is a set that has infinity. So you can make a note of that, right? An infinite set has an untold amount of. So an infinite set has infinite elements. You could never finish that set, right? And a finite set, obviously, has finite number of elements. So as I say, this is a note-taking class, right? So we're taking notes for this one, right? So we have the finite set here, and you can see how we write a finite set. Take a look at this. Because at the end of the day, the set builder set is the set of letters in the alphabet. So this is the set builder form here. right? And you could write it out. So the set of letters in the alphabet, we could write it out in raster form. But if you're not feeling to write out all 26 letters, they start the alphabet here, write dot 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 to show that it continues on, and then they end it here to show that it has an ending, to show that it is a finite set. Yeah, it's only an infinite set that you can start at A, B, C, dot 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 and leave it open like that. You'll do that for an infinite set, right? But for a finite set, you probably might want to show the ending to show that it's finite. So I hope you guys understand the difference between a finite and an infinite set. Now, in maths, we're definitely going to have to deal with numerical sets, and that is sets where we're talking about numbers. Right? So these are some examples of numerical sets. We have here the set of even numbers. Right? We have here the set of odd numbers, and if you guys want, you all to take a note of these things, and you notice the dots here. So the dots here shows that it goes on in this direction to infinity. But then we have dots here showing that, hey, it coming from that direction also to negative infinity. So you have infinity in both directions here. In terms of the set of prime numbers, it starts at 2 and it goes to infinity. Right? Positive multiples of 3 that are less than 10. So this is the set. Positive multiples of 3 that are less than 10. So sometimes they will actually ask you to write out, they will write out a description of the set, and you are going to have to list the elements. Right? So you could tell here that we have many different ways to write sets, and that we'll have to deal with numerical sets as well. Yeah. Now we talked about the universal set, right? The universal set is the set that simply contains everything, right? Or everything that is relevant to the question, or everything that is relevant. Remember, a set is things in common, you know, things that you wear or fingers. So obviously everything pertaining to things that you wear, or everything pertaining to fingers. So it's not like the universal set contains everything in the universe, no, but it definitely contains everything pertaining to what you're talking about, what is relevant to the question. So nice and easy, right? So we usually give the name of the set, right? We will name it in capital letters, right? And to represent the elements of the set, we would use common letters, right? So, for example, right, is if we had a set letters of the alphabet, oops, I forgot to do that. If we had a set letters of the alphabet, right, what I would do is I would use a capital letter to name the set. The set A is equal to the set of, and then I would use common letters to write the elements. You understand? So everybody okay with this, right? Common and capital letters in the use of sets. Yeah? Alright. So for example, A, if you see a A, then that would represent set, a set. And if you see a common A, that represents an element. Right? So when we're talking about elements now, we could see here that there is a way that we could write an element, and that is, look at this notation here. Right? So let's talk about this simple set A, and this set A is the set of numbers 1, 2, and 3, a very small finite set. We could see here that 1 is an element of A, so that's how you write an element. 1 is an element of the set A. But 5 is not an element, so that is how you write 5, and that's how you write is not an element of the set A. So I hope everybody is cool with that. I'm moving on, just Let me know. Right. We saw just now where the set T intersect S was the same as the set T when we were doing that. No, it was T union. Yeah, it was T intersect S. Yes, it was. Right? Is the same as the set E. Both of them were equal, so we're talking about equality. And two sets are equal if they have precisely the same members. So that is what you want to write out of this page. Remember, today is a note-taking class, so you are going to have to be taking these notes, but you don't have to take this entire page. Just write the notes that are important. So when it comes to set equality, two sets are equal if they have precisely the same members. That is what you want to write. Right? So we see here this example. The set A is the set whose members are the first four positive whole numbers. And then the set B is the set 4, 2, 1, 3. So we see that yes, they are equal. Right? So if we look at it, the set A is 1, 2, 3, 4. The set B is 4, 2, 1, 3. Right? And then we could see here that the set A is equal to the set B. Yes, they are the same set. Now, given that they are the same set, what conclusion can you make about the order of the elements? Yes, and that's a very good conclusion to make, Scotia. So we can see here that the order of the elements, and this is an important note, so make this note, right? Does not matter. So it doesn't matter what order you put the elements in. Once they have the same elements, the sets are equal, right? And of course, this is how you write it. A equals B. Subsets. We spoke about a subset. Now let's see the actual definition of a subset, right? When we define a set, if we take pieces of that set, we could form what is called a subset, right? So a subset is a part of a set. A subset is included inside of a set. Yeah. So for example, the subset of this, so we have a bigger set B, right? And the bigger set B, just now I think, okay, sorry. The bigger set B here, we can see the set A is totally inside of the set B. It must be totally inside, right? So the set A is 1, 2, 3 is totally inside the set B. So A is a subset of B. And that is if and only if every element of A is in B. So every element of A is in B. So this here is what we call a proper subset. And honestly, to tell you the truth, I forgot the symbol. You have two types of subsets. You have a proper subset and you have an improper subset. Right? I can't remember which is which though, but we'll see it just now. We'll see the symbols for them just now, right? Now a way to look at something else. We have this other set here, 1, 6. So if I wrote 1 and I wrote 6 outside, you'll see that that set comes like this. Let's call this the set C. So we can see here that the set C definitely intersects. So it intersects the set B. And it also intersects the set A. Right? Because you have this 1 that is in common. However, this set C is not a subset of the set B. because you have this 6 on the outside there. So you cannot say that C is a subset. The subset has to be inside of the entire thing. Everybody understands the subset, right?
Yeah.
All right. Now, just now we will see what the symbols are, the correct symbols. I can't believe I just forget which is which. I just always do that, mix up the proper and the improper, right? Okay, sure. Well, I'll just keep going because it's easy stuff, right? And you can always check the record. All right. Yeah. So A is a subset of B, right? So A is this, B is this. Is that true? Is A a subset of B? Yes, right? Because you can see A have 1, 3, 4, B have 1, 3, and 4. So yes, it's all. So yes, A is a subset of B. Look, the answer was right here. So it's not like you all really had to whip it out or anything, right? So we just going through here. Let's see. Let A be multiples. Nah, we don't really need to do this. Maybe. Yeah, blah. We need to do this, right? All right, right. So now we're talking about proper subsets here now, right? Proper subsets, and are there? Oh, look at here. Not a proper subset. Subset, proper subset, right? Right. So we have a subset or a proper subset. Right. Cool. So now I know the difference, right? So if we look at the definition of subsets, we can see let A be a set. Is every element in A an element in A? So, all right, so take this for example, right? I have the set A is 1, 2, 3, 4. Right? I have the set B, which is 1, 2. All right. Now let me ask you a question. Is every element in B in the set A? Yes.
Yeah.
Is every element in A in the set B? No, right? So we could say here that B is a subset, and this is a proper subset of A. Right? Now let me ask you guys a question, right? Is every element of A inside of A? Yeah, you guess so, right? So that means that A is a subset of itself, eh? Could you say that?
I think so.
Right. So it doesn't seem very proper, does it? Right? So at the end of the day, we'll call this. All right. So let me look at the set C. Right. The set C is the C 1, 2, 3, 4. Is the set C, are all of the elements in the set C the same as the set A? They're all the same, right? So I could say that all of the elements in C are in A. Eh? So I could say that C is a subset of A. Eh? Yeah. The problem is that they're both equivalent. Yes. So because they're both equal, means that this is what we call, and this is where you'll add the line here. This is an improper subset. Right? And this one here is a proper subset. Now, a proper subset is the smaller set, and we call it a proper subset because that is what you would think a proper subset would be. Eh? A proper subset would be normally smaller than the bigger one. Eh? But when you have a subset that is exactly the same as the bigger one, right? In this case, C is pretty much equal to A. So we call this an improper subset. So an improper subset has the same number of elements. An improper subset has the same number of elements. So does everybody understand the difference between a proper subset and an improper subset? Yeah, everybody cool? Soraya, you okay? Alright. Now we have here some symbols here, and we could see here that we used this symbol to mean the set of. This is an intersect, and we didn't really talk about intersections, unions yet. We have a proper subset and we have an improper subset, right? And then we have not a subset. So if something is not a subset, you just cross it off. We have the element of, we have not an element of. And well, this superset thing is actually really easy. We'll get to that just now. So at the end of the day, this PDF has all of the information that you will need to really tackle sets, right? Now we have to talk about this set here, the empty set, right? So let's just talk about, let me see. If we have the set A, and the set A is 1, 2, 3, 4. Then we have the set B, which is 1, 3. We have the set C, which is 2, 4. And we have the set D, which is 5, 6. Right? So let me see if you guys could tell. Now, what is B intersect A? What is that? All right, very good. 1 and 3. Those elements that are common, 1 and 3. But now let me ask you something. What is D intersect A?
It's actually a complement.
Well, is D intersect A, right? Because you're talking about A complement. That means everything that is not an A. Yeah? So that's fine. D is, you could say that D is A complement. A complement, everything that is not an A is really the set D, yeah? Yeah? So that is what you're talking about here, Ariel, right?
Yes.
Yes. And that's actually a really good thing. But what I want is D intersect A. So D intersect A means what elements does D and A have in common? And how many elements do they have in common?
They don't have any other thing.
Right, they have none. So what we say is that this is the empty set. And we write the empty set like this. Yeah? So an empty or null set is probably the weirdest thing about sets. Yeah, I hate these examples, they're dumb, right? So there are no elements in the set, right? Not 1, 0. There are no elements. It is represented by this. It could also be represented if you write, so you could see I could write D intersect A is the empty set like that, or I could write D intersect A is just an empty set like this. Yeah, so these are the two ways that I could write it, right? Now it have one really important thing that you must make a note of. So make a note of this, right? The empty set, which is that, is a subset of all sets. Does that make sense? Does that make sense to y'all?
Yeah.
Right? So if I have this set A, all right, 1, 2, 3, 4. All right, forget about the set A. Let me just say I have a bucket of apples, right? And the bucket have apples in it, right? There's a set of apples, right? So I could dip in my hand and I could pull out a set of 2 apples. I could dip in my hand, I could pull out a set of 3 apples. But if I wanted to, I could dip in my hand and pull out a set of no apples. I could just dip in my hand and not pull out anything. Right? So it is possible that you have the empty set inside of all of your sets, and so you could think about it like that. Right? So just remember, in terms of subsets, we have many different subsets, and we will talk about it just now. We'll talk about that just now. Subsets, right? We have many different subsets, but the empty set is a subset of every single set. Every set has an empty set in it. Nice. All right. So empty sets and subsets. The empty set is a subset of every set, including the empty set itself. So the empty set is a subset of itself, which means that it's an improper subset of itself. So yeah, and as I say, just like how we started number theory from the very basics, and we started arithmetic, algebra from the very basics, we start in sets from the very basics. But you know, things are going to get weird, right? We were saying here the order of a set. Well, the order of the elements does not matter. The order of the elements does not matter, right? However, that is different from the order of a set, right? So the order of a set is something different. When we say the order of a set, what we mean is the size of the set. Yeah, right? And the size of the set is also called the cardinality of the set. So the order of a set equals the cardinality, just a fancy word for it, which means the size of the set. So for example, if I have the set A and the set has 4 elements in it, the order of set A is what? 4. The amount of elements in the set. Right? So the number of elements. That is the order or cardinality of the set. So everybody understands what order or cardinality is?
Yeah.
Alright, very good. Remember, we have something called an infinite set, so therefore those sets would have an order of infinity, right? Nice. So we have a nice little piece of thing here now that we're going to talk about. If I have a set A, and the set A is this. How many subsets are there in this set? What are they? So you have the set with 1, and this is your improper subset, being the same as the actual set. Yeah? Right? And then you have the empty set. Right. Very good. Right? So I have the set B now. And the set B, 1, 2. How many subsets are in the set B? Alright, so first of all, we have the empty set, and then what do we have? We have the set with 1 alone, and then we have the set with 2 alone, and And then we have the improper subset that is the same as the set nth. So how many subsets do we have there? Alright, cool. Let's look at set C. Set C is this. How many subsets are there in set C? I'm looking at Soraya and Caitlin for this one. List them out for me, right? Alright, let's know. That's not I was drinking Maluka say just now. The empty set. Then what? Alright, so the single digit set sent.
Yeah.
So we have the set with 1, we have the set with 2, we have the set with 3, right? So the double digit sets now, eh? So we have the set with 1 and 2. Then we have the set with 1 and 3, eh? And then we have a set with what? With 2 and 3. Any other double digit sets? And then what?
And then 1, 2,
and then the improper subset 1, 2, and 3. So how many subsets do we have? 1, 2, 3, 4, 5, 6, 7, 8 subsets. So with this one, right? So for this one, the elements, the number of elements, and I wouldn't use that. I'll use this. The elements, we have one element, and then the subsets, we have 2 subsets. Right? In this one, the number of elements was 2, and the number of subsets we got out of it was 4 subsets. Right? In this one here, the number of elements was 3, and the subsets that we got out of it was what? 8? Yeah? So D equals 1, 2, 3, 4. So how many subsets am I going to get here? Alright, so first we have the empty set, and then we have what? All of these single digit sets, subsets, right? So with 2, with 3, and with 4. You can tell I'm real tired drawing these curly brackets, right? Yeah, I have the double digit subsets, right? So that is 1 and 2, right? 1 and 3, 1 and 4. Then I have 2, 3, 2, 4. You notice I'm not going to count 2, 1 because we already have 1, 2 and order does not matter, right? Then I have what? 3, 4. I have 3, 1. I have 3, 2. So I'll have 3, 4. And then I have 4, 1. I have 4, 2. I have 4, 3. So that is it. So that is it for the doubles, right? Right. Right. And then now I have the triples now. So I have 1, 2, 3. Then I have what? 1, 2, 4. Then I have 1, 3, 4. Then what else do I have? 2, 3, 4. Then I have 2, 3, 1. No, 1, 2, 3 is already there. 2, 3, 4. Help me out. 2, 3, 1. I already have 1, 2, 3. Is that it? 3, 4, 1. 3, 4, 1. 3, 4, 2. 3, 4, 2. 3, 4. Is that all of the 3 digits?
I think so.
And then we'll have the 4 digit. 1, 2, 3, 4. So let's count and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right. So you can see, let me look at what's going on here with all of these things now, right? If we have, we'll call this the number of elements, and we'll call this one here the number of subsets. We'll come down like this, we'll go like this. Alright? And then we'll say, okay, so when it have one element, it have 2 subsets. When it had 2 elements, it had what? 4 subsets. When it had 3 elements, how much did we get? 8 subsets. When we had 4 elements, how much did we get? 16 subsets. Can anybody guess how many subsets it would be if you had 5 elements? I mean, surely you're seeing a pattern that is developing here, right? Sorry? How you get that? You find that this doubling in size, eh? So 2 times 2 give me the 4, eh? 4 times 2 give me the 8. 8 times 2 give me the 16. So 16 times 2 gonna give me the 32. So with 5, you can expect to have 32 different subsets. Soraya, Ariel, Shizzy, Caitlin. All you understand this? Alright. So yeah. So now here's the question now. Dot dot dot. How many subsets would I have if I had n number of elements? N number of elements. N times 2? Yeah, so n multiplied by 2, 2n. Is that what you're saying, Shizzy? Now, I really love the guess. I really love the guess. But when you make the guess, let's test it and see. Right? So let's test it and see. So this one have 1 element. So that means that it will be n, which is 1 times 2, and that gives us 2. So it works here. This one have 2 elements. So 2 times 2, that gives us 4. So it works here. This one have 3 elements. So 3 times 2 gives us 6. Does not work there. This one have 4 elements. So 4 times 2 gives us 8. So it does not work here. So therefore, it is not it. So it's not 2n, but I really love the try though. That is a really great try. And I should probably leave earlier with this for homework, eh? To see if I could come up with a formula that will satisfy all of this. Anybody could come up with it now, or you all want it for homework? 2n squared. I'll tell you something though, Ariel. You're on the right track. Right? So let me try 2n squared and see. 2n squared. So the number of elements is 1, so n is 1. 1 squared is 1 times 2 is 2, so it works here. The number of elements is 2, so 2 squared is 4 times 2. 4 2s are 8, so it does not work here. and it probably wouldn't work going down the line. So I'm afraid that it is not 2n squared. Anybody else could tell me? Nobody? N squared. Let's check it and see. So if it was n squared, then in this case n is 1. So 1 squared is 1. So it doesn't work from the beginning. Right, so your homework is this. This is your homework. Come up with a formula, because I'm noticing a pattern here. When I have one element in the set, I have two. Two subsets can be formed. If I have 2 elements, 4 subsets can be formed. If I have 3 elements, 8 subsets can be formed. If I have 4 elements, 16 subsets can be formed. If I have 5 elements, 32 subsets can be formed. Let me see. I'll give you all one hint. Right? That is your hint. Let me see if anybody could get it. And if nobody could get it, then you'll get it for homework. Right? So we spoke about all of these things. We spoke about subsets, improper subsets. Next class we're gonna finish sets. Next class we're gonna talk a little bit more about unions, intersections, complements. We're gonna talk a little bit more about Venn diagrams. And then next class we'll start some questions. So next class we'll finish sets, and then we'll probably spend 2 classes after that doing questions on sets. And you'll see that questions on sets will scramble your brain. And you know, it actually involves a lot of algebra, which is one of the reasons why I did algebra early on, because everything that we will do from now on will involve algebra, right? So yes, that is set theory, the introduction to set theory. And the homework, if it is you did not already figure it out, see if you could figure out a formula for the number of subsets in any given set, right? There must be a way for us to find out what are the number of subsets in any set. All of the different ways that you could rearrange a set, right? So any questions? Anybody have any issues with anything we did today? Anything puzzling or confusing? Yes. Yes. And that was the whole point of the class today as well. Caitlin, you alright?
So, I have a question. So, actually, no, because after prep for next class.
Yeah, no problem. I'll be done. So it's fine. No problem.
So it was nice meeting you.
Actually, I'll just say goodbye to everybody. Everybody have their homework. So Tuesday we'll talk about it, and then we'll finish sets on Tuesday. So yes, so you have that one thing to do for homework. It's not no pilot questions. So everybody have a good day. Soraya, it was nice having you in the class, and I'll. Yes.
Okay, bye.
Definitely. So bye guys. I'll see you all Tuesday.